As I was saying, we can find nitrogen's atomic mass to be 14.01. Using these two values and the subscripts in the formula, so tin subscript is 3, nitrogen is 2, I'm going to take the 118.69 times 2 and add that to 1401, 1.69 times 3, excuse me, and add it to the 14.01 times 2. I'm going to plug that all into my calculator. Showing you how we can use our calculator to help us here. 118.69 times 3 plus 14.01 times 2, and that equals 384.09, and that's grams per mole. That's telling us if we had 1 mole of tin nitride, we would happen to have 384 grams of tin nitride. Next problem is a little bit more complicated. We need to analyze what those parentheses and the subscripts mean. So there's 3 copies of magnesium. That should be pretty straightforward. And then we have the phosphate ion, but there's 2 copies of that. The subscript 2 distributes to both of those atoms in there for a total of 2 phosphoruses, and then 2 times 4 makes 8 oxygens. So looking at that whole formula, and then off the periodic table, so we're looking for the atomic masses off the periodic table, magnesium phosphate. Magnesium weighs 24.31 times 3 copies, plus phosphorus weighs 30.97. And again, these are coming off the periodic table. I'm looking at the atom square, atomic mass, and I'm multiplying it by the subscripts. And oxygen weighs 16. 2 times 4 makes 8. 8 copies. Plug this all into the calculator. 24.31 times 3 plus 30.97 times 2 plus 16 times 8 equals a total of 262.87. And again, the unit, which is important, is grams per mole. We're not going to round these numbers at all. We're going to use them straight up, whatever they happen to be. Strontium chloride. We have 1 copy of strontium, 2 copies of chlorine. Hopefully that's straightforward. There's no subscript, which implies 1, and 2 copies of chlorine. Strontium, my periodic table says is 87.62. Since there's only 1 copy, I just need to add that to chlorine, which my periodic says 35.45 times 2. Oops, my apologies. 87.62 plus 35.45 times 2 equals a total of 158.52. That's grams per mole. Okay, we have nitric acid here, HNO3. The periodic says hydrogen weighs 1.01, nitrogen weighs 14.01, and then oxygen, there's 3 copies, so 16 times 3. 1.01 plus 14.01 plus 16 times 3. 63.02, and that's grams per mole. Let's see the answer. Next problem is calcium oxide. So I'll write the work down. Periodic table says that calcium weighs 40.08. And oxygen we've used a number of times is 16. 4008 plus 16 gives me 5608 grams per mole. Nitrogen monoxide. Nitrogen weighs 1401. And oxygen weighs 1600, which gives me 30.01 grams per mole. Ammonium nitrate, H4NO3. You can solve this in a couple of different ways. You could put the two nitrogens together, you could just run them separately. So 1401 plus 1.01 times 4 plus 1401 plus 16 times 3. Plugging that all in, 1401 plus 1.01 times 4 plus the 1401 from the second nitrogen and 16 times 3 equals 80.06. And then the last problem, that's a fairly difficult problem as well. We have calcium phosphate. Again, need to analyze what all those subscripts parentheses mean. 3 copies of calcium, 2 copies of the phosphate ion, and remember that this 2 gets distributed to both of the atoms inside the parentheses. So we have a total of 2 phosphorus, and 2 times 4 makes 8. Common mistake is students think that this is 2 plus 4 giving us 6, but it's 2 times 40.08 times 3 plus 30.97 times 2. And then lastly, 1600 times 8. We're going to take those values, plug them in. For a final value of 310.18 grams per mole.